All right, I am super excited for this next talk. We have Thomas. He's going to be talking to us about WebRTC and jQuery. We had a presentation last week from India. This one's coming to us from Singapore. So this really is kind of a global conference, and I'm really excited to see where we go with this. So as soon as we get Thomas's video back up here, we'll let him take this away.
Whoa. Hello, everybody. Thanks for joining me from Singapore. Sunny morning over here. It's like 10 a.m. or so, you can see. So I hope this is coming through quite well. Like, I'm pretty far away, but so far we hadn't had a problem. And I was able to check out Aaron's talk before as well, very fluidly. So I want to talk a little bit about WebRTC and the lack of options that allow you to use WebRTC as easily as jQuery. That's kind of the idea behind it. And so just to get you started a little bit about myself, in case you don't know, everybody just knows me. I do web development for quite a while now. I'm a UX designer. I organize Asia's JSConf. Like if you live in the US, you might have heard about JSConf over there in Florida. I do the event here in Asia for the 4th year. Help a lot of startups over here. And I help for the last year a lot of companies and developers to use WebRTC. And on that way, learned a lot of things about WebRTC, the little differences and difficulties. And I want to share what I learned in the last year, helping a lot of people, and what I and my team here in Singapore did to make it more accessible for others as well. Like, because we wanted to package that learning into something that other people can reuse to get started quicker and solve all these hassles and problems and not need to go through the same thing again that we went through. So what is WebRTC? Yeah, show of hands doesn't really work that easy in a chat. Like if you just want to type a plus with WebRTC before in the chat, exactly, give me a hand raise if you have. I'll go through the very basics of it, not very deep dive. For that, I'm happy to do another talk at the Next.js Remote Conf if there's demand on how the intricacies of WebRTC really work. But in general, on a high level, WebRTC is a set of JavaScript APIs in the browser that enable browsers to talk peer-to-peer with each other without going through a server. So the main difference in that is that happens like this. Everybody's connected to a server and you get the responses from the server as well. This is even how modern real-time communication kind of works if you use a Facebook message or a WhatsApp. You're actually talking to a server and the server relays that information to somebody else. Now, peer-to-peer works slightly different. It's like everybody talks to everybody. There is no server involved. Why would anybody want to do that? Because it gives you essentially a very, very low latency on the connection. You need to do in low latency or privacy for that matter. Like going through a server means there's always somebody listening to everything that you're writing, saying, sharing, which you might not want to do. You can actually do this directly peer-to-peer. I mean, by now you go through routers, which are kind of computers or servers by now too. So ask your local NSA what they really do with that data. But in general, that's the idea, is that through the direct connection, you get the fastest path from one device to another device. And that gives you low latency, and it enables real-time communication. And this is why everybody connects WebRTC to this typical use case of audio video. Like essentially what we do right now with this Click webinar software is also, in a way, real-time communication and can be done with WebRTC. I'll give you a lot of examples and demos later on what is possible with it, and a few code walkthroughs as well on how you can actually solve some of these problems as well. Some of the use cases for WebRTC include one-on-one calling. You want to call somebody like a FaceTime on your iPhone. conferencing, like having a conversation with 5, 6, 7 people and exchanging like an online meeting, right? Everybody knows GoToMeeting, I guess. In-game chatting can be a real-time thing where you don't necessarily need a server. Virtual co-working, I don't know, where you essentially hang out in a Slack kind of room with like a lot of other people, and you actually can see and hear each other. You can do music streaming, which is great if you have low latency. It's a requirement, to be honest, to do that. Like if you have a sensor network, like mesh networks get very popular these days too. They're kind of a peer-to-peer thing, and WebRTC could power them. You have e-mentoring, online video consultation, a JS remote conf. Why not? Like these are some examples. So traditionally works in a way where you go to a website and you want to talk to somebody, and it usually shows you a phone number, and you type that phone number into your phone, or you swap to your phone device, your phone app on your phone, right? Like to actually dial that number. Or you exchange a Skype username and say like, hey, you know, like add me on Skype and we do audio video calling there, or you install a software like Click Webinar to participate in this conference. You get somebody's Gmail address, add him as a contact, and use Hangouts. So the barrier of entry in it, in the sense that there's always something you need to do, something that like you need to add a person, you need to sign up for an account, and WebRTC can essentially solve all of that. It makes it very barrier-free to embed communication into your web application or app, actually. So here's some of the examples where WebRTC could be helpful already. Let's say you booked an Airbnb. You could essentially call your host through the Airbnb app or through the Airbnb web call. The audio calling could be embedded into that website. And I listed a few other examples here on who you could talk to. And you see a pattern that switches away from communication, the phone, or a phone call being this thing on the side. I mean, in the past, it used to be a device sitting in the corner, you know, on a wire, and you had to walk over when it rang and like, yeah, pick up the call over there. It was a total different thing. I think WebRTC is going to be the driver that enables in-context communication, contextual communication, in the sense that you can talk to people and communicate with people, exchange data with people in the context that you are acting or interacting with them already. Like on Airbnb, you have kind of a guest-host relationship. On Uber, maybe like a passenger-driver relationship, right? But it is in context. And I think that's very, very powerful to get started with. And the problem with that is it is a set of APIs that is very cryptic. It requires you to do a lot of work. I get into the nitty-gritties of that a bit in a bit. But conceptually, I want to show you how it works and then talk you through on how we can make that easy to use as a jQuery, where you subscribe a few events, where you call a few functions, and the rest just happens to work. So a WebRTC call from a high level, which will work kind of like we have person A and person B. Usually Alice and Bob in every example. That's one A and B. And if they want to talk to each other, it's kind of a problem because the devices don't know each other yet. They have no sense of this is the other person I want to call. So what you need in a way is, and Bob know, that they can go talk to and say like, hey, I really want to be in this conversation with Alice or conversation with Bob, and both go there with the same kind of information. And then the known party introduces each other, essentially exchanging your network address and an open port, or an openable port to be exact, so that a peer-to-peer connection between the two browsers in that case. So, and you can start exchanging data between the two. So that is WebRTC conceptually in a nutshell, meaning you essentially need the known party in the background introducing. It's in a way, it's a bit like asking for an introduction on LinkedIn or even in real life, where you have this other friend that needs to introduce you to. And actually, there are even more similarities because then you need to find out later, like, what languages do you really speak that you should converse in, like what's compatible. And this is all happening through WebRTC in a negotiation process. So to make it easier, like my team and I, we came up with a bundle of tools called Skylink, where we put all of that in to make it super, super easy to use. So on the client side, this is Alice and Bob. These are the browsers. This is the JavaScript code that is executed and run in your browser that you want to write. And to go to Andrew's question, WebRTC traffic is encrypted by default. Yes, that is true. So to get started with the client side, the JavaScript code that you want to execute there to start this process can be quite complex if you want to do it from scratch and you don't use a helper library. This is essentially the most complete chart that we've tried to come up with on how this process works. So it's not super straightforward, but it has something to do on the lines of introducing two people, essentially saying hi to each other, and then trying to figure out, hey, what languages do we speak? What languages can we agree on exchanging with? And that language codec or an audio codec, because browsers support different kinds of those. Like usually Firefox had historically a bit of a problem with H.264 because it is not it is highly IP protected, and so there are license fees, and as an open source software, Firefox had a problem porting that into their source code base, and eventually Cisco came for a rescue, and there was a whole story about this, that H.264 now works in Firefox too. But traditionally, Firefox could only use open source codecs, so it would offer, for example, Google's VP8 need to agree on that, so they exchange these local offers until they can agree on something that works for them. And it's a bit of an intricate process where you need to find out who's going to start the conversation, the awkward moment in the beginning, until they actually start negotiating and exchanging candidates, saying like, hey, I think you can actually talk to me over this port at this IP address. Like, why don't you test that? And there might be multiple network interfaces available like that. And so this is exchanged through this known party saying like, hey, try here to connect to me. This is the candidate introduction. So there are helper libraries like that, like Peer.js and simple WebRTC, that help you not dealing with all this complexity and rewriting this process with a signaling server. One of those we filled in as well, that is Skylink.js, which we essentially tried to mimic a little bit to the ease of use of a jQuery, where you subscribe a few events, you fill in your code, and the rest happens almost magically in a little bit. And I can show you a lot of demos on that in a bit, just to show you how simple the process actually becomes, how useful that actually is. Then WebRTC is, as far as I know, still not an official standard. It is a draft and process to become a standard. It's still hanging in the W3C consortium, and people are arguing about the final issues with it. But there are browsers already for supporting it for 2 years, and these browsers are Chrome, Firefox, and Opera. But the implementation in these browsers is a little bit different here, a little bit different here. Though there wouldn't be different browsers if they wouldn't have slight differences in everything. We know this from the past very well. Like if you do web development like I did for 15 years, yeah, you hate kind of the old Internet Explorer mentality of always doing their own thing and so on. And so in a way, WebRTC is still a very young technology, and the implementations vary a little. And so you want something that helps you essentially polyfilling WebRTC in a way, or shimming is the right word here, I think. Polyfilling is essentially making it available in browsers where it is not available yet, but shimming, so that the API in all browsers looks the same, acts the same, does the same thing. So you can write code for your application instead of worrying about, oh, I'm in Firefox, so I need to do this workaround, or I'm in Chrome, so it supports this feature, which is not yet in Firefox. So you want something that helps you with that. And there's a library called Adapter.js, It was initially created by Google and part of the WebRTC demo that they have published for WebRTC. And we tried, like, we found this really useful, and we thought, like, it's great, but it's not yet super complete. So we've essentially forked it from them and built around it. And so it's a drop-in replacement for Google's Adapter.js. So if you already use a project like that, you could essentially just replace the two and it would still work. But it adds even more. And I want to go through this a little bit just to show you how that essentially works. So maybe let's see if that desktop sharing actually works. Unexpected Adobe Air problem. Let's try that again. Okay, I'll try that again when it offers me to try again. Like, it throws you out for like a few seconds before you can do screen sharing again. Okay, I'll go through this presentation maybe first and then come to the demos and browse through these libraries a little bit later. The next thing is that WebRTC is still not supported officially in IE and Safari. Sorry, not officially, also unofficially, it's not supported. It's just no code in these browsers to execute WebRTC. So that's, I think, the biggest holdback for this technology, because Safari, and specifically IE, are still widely in use on this planet. And so therefore, barely any company really has put all their eggs into the WebRTC basket, because it's just not available on all the platforms right now. And so seeing that, we essentially threw some effort into making that work as well and wrote the only WebRTC plugin available for IE and Safari that actually works well and is not proprietary. It's upgrading Safari and IE to support WebRTC, and that's available for free download. I'll share this slide deck later, and you can go and check out all the links and download all these tools yourself. But it allows Safari and IE users, if they enter a website that wants to use WebRTC, to download and install this free plugin to upgrade their browser to support any kind of WebRTC. That's not proprietary to our technology or anything. It's just upgrading these browsers to do it through a tricky mechanism. Like, it's not really an extension of the browser, it's a browser plugin, and it works in the background like weirdly similar to like what Flash does, and it has a few sad exceptions in a way. Like, it doesn't work in an iframe right now, and like you cannot access it as a normal video tag later, meaning some functions don't work yet, and we're still trying to figure it out. Like, there's one demo that you see later where I take a video picture and I draw a JPEG out of it in a canvas, or I draw on the canvas from the video and then save it as a JPEG. And that is something that the plugin sadly can't do yet. But for audio-video conversation, it works incredibly well already. And you can try out this website getaroom.io already if you like. It's fully upgraded and works in every browser. So then on the server side, you need this known host, this third party that both clients can connect to essentially get introduced to each other. And here you would usually set up your own server, like an EC2 instance. You need to obviously maintain it yourself. You need to scale it yourself in case you're writing something really ambitious. And it needs to communicate, like, understand and forward the lingo of your client side. So for this kind of socket, or for this kind of signaling connection, you can use all kinds of different technologies. A lot of people use WebSockets. That's what we do too. But I had a friend of mine who used iMessages. Well, it sounds a bit weird, like, and he actually used human interface, meaning he was typing the network candidates and protocols into an iMessage on his phone. Then they get received at the other side, and he types them back into the application, and that way they exchanged their network protocol. It works too. It's a bit cumbersome, a lot of typing involved, and like, but you can use iMessages for signaling. Not sure it's necessarily super maintainable. Okay, I see a question popping up. The plugin does not work on mobile Safari. That's a very sad story. But even there, we are trying to pull through and make something work. There is a browser from Ericsson that I can't necessarily recommend because it's not a great browser, but it supports WebRTC. So maybe it is a great browser. And it's called Bowser. I can show you the icon if you like. It's right there in the corner. And that is a browser for the iPhone that uses WebKit in the background and then extends WebKit with the functionality of WebRTC. Like every time I tried it, it's actually quite shaky, but feel free to try it out. It's free for download, and they announced that they're going to continue to develop on it. So that's one option. In Safari on iOS, it otherwise doesn't work, but even there is our little Singaporean company working and fighting with and against Apple. So maybe by the end of the year, we have some news on that side as well. So, but it's definitely going to come. It's just a matter of time. Like I know for a fact that Apple doesn't have anything against WebRTC in that sense. They just don't put it as a priority. So if you would like to use this kind of technology, you need this known party. And there are server-side libraries that you can run on your own instance if you like Peer.js is a good example. Or you use a platform like the Skylink platform that we've created, where you essentially get unlimited signaling as a service. You can just go there. Like right now, it's free as well. So you can just use us as a third party, and we do all the signaling in the background for you. So what about mobile? Another question in the chat. Portable plugins. That would be another idea to follow. We haven't thought about that one yet. Yes. So I'll get to that a bit later about the native iOS. So if it doesn't work on mobile, it's not worth doing. That was a quote of a friend of mine at the JS Conf here in Asia, and I think it's true, specifically in Asia, where there are billions of people coming online on a mobile phone. They have never used a computer before, maybe only seen one in the far, but it's a whole different generation growing up here in Asia, in Indonesia, and large rural parts of China. So it needs to work on mobile, right? So good news is it works on mobile, or at least on Android mobile, it works on Chrome, in Firefox, and in Opera already. Not in the native Android browsers that are sometimes shipped with your phone. Like if, I don't know, like I have a Chinese Xiaomi phone.
Thomas, you still there? Hello, Thomas?
Hello?
Oh,
Hi.
there you are.
Okay, it still all looks good from my side. I'm not sure what happened.
Yeah, just disconnected for a minute.
Okay. Well, now it looks all good again, so I'll keep going. So if you actually want to fill in native applications, I mean, this is a JS conference, so I'm not going to go deep into this, but we have native SDKs for Android and iOS that you can use. So I hope everybody can see me again. Okay. So they're available for download if you ask us, and you can start playing with it. And they connect to a browser as well. Meaning, and I show this in a bit, you can actually make a call from an iPhone native app to the web browser. That's not a big problem. So, well, it's always edge cases, right? What about those? I mean, it's a complex technology. WebRTC relies on a lot of things working incredibly well. Some of those things being the browsers agreeing and supporting the same kind of codecs, the network being accessible so that you can open ports and establish a peer-to-peer connection, the network bandwidth being like good enough so that you can actually transfer the amount of data fast enough. Specifically for video and audio, you usually want to be within a second of latency maximum. Otherwise, a conversation is really awkward if you have to wait 3-4 seconds for somebody to reply. So there's a lot of complex technology in the background that has to go just right to make a WebRTC call work. And so that involves dealing with a lot of edge cases that occur statistically quite frequently, if you think about the absolute numbers. And one of those might be enterprise firewalls prevent peer-to-peer connections requests to come through. Essentially, you work in a big corporation, the network engineers usually tie down your ports so hard that it's hard to get a peer-to-peer connection poked through. And like this is why Skype got very popular early 2000, because they had put a lot of effort into these technologies that help you discovering open network ports. Skype was known as the software that seemingly just worked, whereas everybody else was struggling and you had to open ports manually on your router. And I don't know if you've ever tried that at the time, but it was really cumbersome. Or you have a shitty Chinese phone. Again, sorry if the stream goes back again, like might be really China, I don't know. And it can't handle like 3, 4, 5 video streams to be sent out and retrieved with all the encryption and encoding involved. So in these cases, there are actually servers that can help you, and we have some of them available in our infrastructure as well. Like a stun server is a server that helps you identifying connection options by looking at you from the outside. So you can go there as a client and saying, hey, I want to open a network port. I can't really see all my network interfaces. Please, server, help me, look at me. What do you see? So that's what a stun server does. And the turn server is the next step on top of that. Is like if the stun essentially says, I can't find anything, then the last and only option is that the server relays your video, which adds latency to it again. So it's not necessarily something we want, but then on the other side, it's better to do that than not having any video go through. So the turn server is a relay server that takes your video stream and funnels it through to the other party, and on the other side takes the video from the other party and like scans it through to you. But the difference is you connected to it, so it is allowed to exchange that data. It's not another party poking into you peer-to-peer. And on the CPU and network, there's something called an SFU, or if you are in the scene that exists, you might know this as an MCU as well. MCU is a multicast unit, and SFU is a selective forwarding unit. So they work slightly different. An SFU essentially, okay, let's do the math. We have a conversation with 5 people, meaning your computer sends out 4 video streams of your camera to these other 4 people, and it receives a single video from everybody of those 4 people, meaning you end up with 8 streams. That's a lot of video processing to do, lots of video encoding, encrypting, and the SFU can help you reduce that. So the SFU essentially takes 1 video from you and gives you 4 back. So suddenly you are at 5 video streams for the same kind of conf. Again. It flickered again. I hope you can still hear me. Yeah, good. Okay, great. So yeah, the SFU essentially reduces the math for you and relays all the video streams that it receives to everybody. And an MCU would be the next step as well, where you send 1 video and you receive 1 video. So the MCU mixes the video streams that it receives, packages them into 1 video, and sends that video to everybody. So that takes a lot of computing power, increases the latency even more. So should be used only in edge cases, but it can help in a lot of ways to reduce the bandwidth required and to make a better experience on that send. So, and then let's get to the fun part of this talk. Like I want to see you. Like I said, I share this link of the presentation. Actually, let me do this right now already. I think I have this open. I uploaded this yesterday. Here we go. You can just copy this into the chat for people to check out. If you want to go to the last page, you can get the link to all these demos. And I'll try again to share my desktop so you can see what is happening. Yes, it works. Great. So I think people can see my desktop. Don't worry about the Spanish. It's just me being weird. Where do we start? Maybe at first, I'll show you a little bit about the infrastructural background behind this this known host, the signaling service that we have. So with every API key that you register in this, it spawns a realm. In this realm, you can define unique rooms, meaning you just make up a string, and that string will be what both parties need to know to be able to enter the same context in which they can exchange data. So I think it's an interesting concept. It's a very peer-to-peer-ish concept. But if you think about that, every exchange, every conversation between humans and devices usually happens in some kind of context. Think of the room as that context. So if you are using it for a client-doctor consulting session, essentially this conversation is the one context. It's this like patient-doctor relationship, and the room identifier should be representing that. So if both peers know the same room identifier, they can connect to each other. They get introduced to each other by the infrastructure in the background. And in every realm, a unique room ID can only exist once. Right? That's why they're unique. But if you have multiple different API keys, you essentially can reuse the same room multiple times, but people there wouldn't be introduced. So that's the whole difference, just in case you're wondering later. But you can extend API keys with alias keys. Let's say you want to have an application where Android and iPhone apps want to communicate with the web browser. Well, you want to create one API key and two alias keys that share this realm, so that like everybody gets introduced to everybody, and then you can have conversations from iPhone to browser and so on. So I encourage you to read this through. It's a little getting started tutorial that I wrote. And please give me feedback on these kind of things. So the first example is a really quick one, which is here at the bottom of the getting started. Essentially, you need to embed like this one line of JavaScript, this jQuery for JavaScript that I was talking about earlier. And the HTML is really not very, very complex. It's one video tag that I mirror right now so that you see yourself mirrored. It's a bit more natural. So I usually recommend people doing that. You instantiate a new object, Skylink object, and you subscribe certain events that happen. So a peer joined event is an event that is triggered whenever another peer joins the room, and that peer can be yourself. So you get the information in this function passed on, like, who's this peer? Give me some info about this peer, like what audio codecs is he using, what video codecs is he using, if you really want to see that. But there's also a user data element in which you can pass through like a username or a user ID. And if maybe even a small base64 encoded avatar or something that you can send in this user data. Then you have the incoming stream event, which essentially triggers whenever a new audio or audio-video stream arrives on your end, and it's passed in with this stream event, and all you really need to do is use this function through the adapter.js library that helps you connecting it to the video tag that you created. What happens when a peer leaves? What happens if the user grants access to his camera? You get the stream of the user, obviously. And in the end, you initialize to the room, meaning you use your API key and you pick a room name, and you connect to it with join room audio video true. And you have an audio video conference. I can show this here if you like, where you click start in this little CodePen demo. Open the same demo in a new tab. Click start here to allow access to my camera. And now these two tabs have an audio video conversation with each other. So it's really that simple, and it's like 30 lines of JavaScript code. I'll swap back to your chat really quick in case you have any questions there. Here. So far, so good. Like, Chuck, feel free to like just talk over as well if see people having questions. I think that was pretty cool with Aaron.
Okay, we'll do.
Okay. Simple to understand. So this is for a simple conference, and you could go up on a normal desktop computer like to 8 to 10 people roundabout until it starts getting very CPU intensive. It also depends on the size you render the video and the video resolution you're sending, and a few other parameters. On a modern Android device, like Samsung, the newest one, what's called 5, whatever, not a Samsung person. Like you could, we have tried it with 5 video streams, audio video streams on a mobile phone in a website. So I think that was actually pretty impressive. Another example that I want to show you is a one-on-one calling, which works slightly different because the difference between conferencing and calling is that in calling, the person being called is not, like before it's being called, it's not aware that it wants to join a call. That's the main difference between conferencing and calling. Conferencing, both parties know at this time we need to be at a certain point, and you come there. So that's pretty easy. Calling is a bit more difficult because you don't know when you're being called. So you can use Skylink to solve that problem as well. Like it's the JavaScript code is here in this code pen as well. It's not too much. It's like, let's see how many lines of code. About like 150 lines of code that I put in here with some helper functions. But in the end, maybe I can just close the other two here and move this aside a little. You can see I only use Skylink here. I don't use even jQuery, although you could obviously mix the two. But I thought I keep it as raw as possible. Like, so I really do like my DOM requests itself with create element and then all this nasty stuff. But in the end, it's the same functions. What do I do when a stream comes in? What do I do when a peer joins? What do I do when a peer leaves? When a message comes in? I think it's rather straightforward to understand. Like, here's the differences of the message. It's just a big if else right now that I put in here. So I tried to keep the code very, very simple and straightforward to read so that nobody should have a problem understanding what it does. In the end, you connect to the infrastructure again. And here are the helper functions to make it feel more like a phone call. So if you think of a phone call, what you do, right? You pick up, you hang up, you call somebody. So these things kind of need to work. So when I do this here, I have 2 tabs open, both on the same website, and they both generate themselves a unique identifier. And if you upgrade an app that you already have to support this calling feature, you could just use your existing user ID of people that are already registered with your app, right? And so they would connect to a room with their user ID from your app and just hang in there and wait. So they're connected to this known third party, to the signaling server in the background. And as soon as one calls the other, and I'm now doing this by taking the ID from one tab into the other and say call, what will happen, the one tab joins the session of the other tab. I show a little pop-up message that I'm being called. I say accept. Then I'm being asked to share my camera and microphone. On the other side, I'm being asked to share my camera and microphone. And here we are. And this is with audio too, so I hear echoed now, which is really weird. Okay, let's hang up. So this is how calling works. Whoa, somebody's calling me. That must be one of you guys trying out the demo. Let's see, who's there? No? Oh, I closed the wrong tab maybe. Sorry. Maybe you can try again with that ID. Because if you go to the same website, it essentially like, it works, right? You can actually call me. I'll give you an opportunity later maybe to show up in the screen sharing, if you like, through another demo. So if you just want to try it out with the adapter.js, let me see. This is our adapter.js library. And here I just want to brush through really quick on what it does. So it polyfills all these things that are combined known as the WebRTC API in your browser. Meaning in IE and Safari, these things don't exist. And our plugin makes them available. And you need this adapter.js library on your client side to be able to support the plugin. But you can use and program WebRTC pretty much like you would do without the plugin. But one difference, which you don't need to do, like it still works without it, but we recommend it very much, is using this on WebRTC ready because the plugin is a third-party piece of software that needs to be loaded and started when a certain website is being accessed. And that might take a second or two. So if you not use this event, what we will do is we polyfill the RTC peer connection and every other constructor of these objects. But because there is no ES6 in every browser yet, meaning we cannot just yield a function, like specifically a constructor, like a constructor needs to have a return value for WebRTC to be compatible. So we cannot just pause in the middle of the function execution and say, like, wait until the plugin is ready and then return. Would be nice, but in ES5, that's not a thing. We do an infinite for loop, and that takes a lot of CPU power. So it works, but on slow machines, you might see a little beach ball popping up, which we can't really do much about other than educating people to use this function and only execute WebRTC code once this function is called. That's like the only difference that you really need to do in terms of coding with the plugin rather than without. Because this is being called by the plugin, so it's definitely loaded at that point. Then we have a lot of helper functions we took over from the Google Adapter.js to be drop-in compatible with it. Like the attached media stream, there's a difference in the way a stream is attached to a video tag in Mozilla and Google Chrome. So this function takes care of the differences. The same is for ice server creation, in case you ever want to do this wild process that I showed you earlier yourself. You will find this very helpful. There's a check ice connection state. So here you can see this is how it should be in every browser. And for weird reasons, the browsers implement it slightly different. And so in Chrome, it's usually like this. In Firefox, they skip the completed part totally. So what we do, if you wrap it around this function, it will give you the right order and the complete list of all the events that are supposed to fire in the WebRTC standard, so that you don't have to deal with these differences. And there's a lot more in here. Like essentially everything that we find that is a bit different in the different browsers, we kind of try to throw into this library and keep it updated, and like feel free to contribute to it. It's on GitHub, it's all open source. So you can give us pull requests, and people do when they don't like something, when they think we're stupid, or when they think they have something that really needs to be in there. Yeah, and then the other one, Skylink, is also completely open source. That's our jQuery for WebRTC. Here's a link to the getting started. We have a complete API doc as well that I want to show you, that allows you to see all the different methods that we have, from file transfers to user data settings, the whole join room, leave room, lock room, mute a stream, send blob data, send messages. This is going through the signaling channels with the known party, and this is going peer-to-peer directly via the channel. Unlock rooms and so on, and it comes with a complete list of all the events as well, that you can subscribe to update a UI and share with the user that something is happening in the background, like we are connecting, we are being connected, a new peer joins, a peer leaves, a peer restarted the peer connection, and so on. So here you find the list of these things with a complete list of all the parameters that are being passed to you. Yeah, and if you would then want to try it out a little bit more, I wrote a lot of demos for this as well. One of those I want to show you is my virtual co-working platform, like where I wrote my own Slack. That's really what it is. So in case you want to check it out, like it's on serenimo.github.io/coworking, and the code is available open source as well. It's about 300 lines of code, so it's not very complex. You know, in case you ever wondered how hard it would be to write your own Slack. So this supports GitHub Flavoured Markdown, so you can do like funky, oh, that's a weird name actually. So like it asks you for your name in the first way, and like now I can see different people already in here because I have other computers in this room right now. So you can see myself from different angles in a way. And this one here is currently blurred, because if I leave the screen, like I tap out, my own picture blurs so that I get a bit more privacy. So that I thought was an interesting little feature to add to this. And what I use here in the background is I take the live video from the camera, and every 5 seconds I snap a picture of it by rendering it on a canvas. And I can show you how that works. I have the code open right here. So again, very, very simple code. I didn't try to be fancy here or use sophisticated libraries or frameworks. It's essentially just using our Skylink library here. And then a few help functions like how to blur, which turned out to be much more complicated than I thought. So I just copy pasted this off Stack Overflow, I think. How to convert a data URL to a blob, and how to convert a blob to a data URL. And a few other things that I didn't really want to write myself, so I put them in this helper. And other than that, it's essentially just using Skylink and then very, very basic JavaScript, where I define a few variables up here. Again, incoming stream, incoming message, data transfer state. I use our data transfer API to essentially send like the JPEG information that was captured on one side to everybody else. And therefore, I need to convert it blob to data URL. There are different formats that you need to swap around with. It's like kind of, I think the data URL is closer to base64, and the blob is really a binary kind of blob of data that we can transfer through WebRTC. And so I swap between those two before I send it. Then what happens if the user grants access to his camera? The message, thanks, may I know your name? What happens if the user declines? Then peer joins, peer leaves, the init again with the API key. And then I want a very low resolution video, so I can specify this specifically. Then a lot of text and a few helper functions on how do I add a user image to the bar on the top? How do I add a message to the chat window? How do I replay the chat history so it supports local storage? And you saw this like with all these like old messages suddenly popping up, and it always uses your current picture as your avatar. So that's kind of cool, I think. And here's the capture function in a timeout every 5 seconds, and it essentially just gets from like from a canvas the context in 2D, and then draws the video tag onto the canvas. I mean, this is really as easy as it gets to like capture a picture from the live video of your camera. It's just feed a video tag into the draw image function of a canvas. I think that's pretty neat. And in the end, you can say this photo canvas, you convert to data URL, and this is a native API of the canvas. And you say, I want a JPEG in this compression. And here we have somebody else joining the room. Hello. So we have some, like I was playing around with volume as well. The idea was to create a co-working space so that you hear like a very like low volume ambient noise from everybody in this co-working environment to give you the feeling you're sitting in a room with everybody else. And only if you swap back to this tab, you essentially start being visible for everybody else. So it's an interesting demo, I think. Which brings me to the last demo that I want to show you, which is something that you can use every day as well. Maybe you have heard about Firefox Hello, which uses WebRTC to make one-on-one calls working. And like we wrote a little tech demo as well, which is absolutely open source. So you can just click on the fork me on GitHub button here, and it gives you the source code of this whole thing. And it runs on our Skylink library and React, Facebook React. Go React. Hey Mel, I can see you too. Yeah, I see still other people joining. So in this get a room, I have again like another computer set up here. So depending on what you put behind the slash, you can essentially start a call. And this identifier that's behind the slash is essentially the unique identifier of your room. So everybody of you that would go into this room right now would see me and the amazing frog in front of Mel's CSSConf logo from last year and our little toy helicopter. So let's see if somebody makes it. If not, I'll try. And to show you that that actually works well, if you check here, this is on 4G. So this is not going through the same Wi-Fi. And I'll just, yeah, hey, we have somebody. How are you doing? So I'll try, like through 4G as well. Let's see, one of those might be me. Yeah, there we go. So this is now me through 4G in the same room on my iPhone. Right, there we go. So this is using our native SDK. And you can see the performance is actually quite good for going through the internet. It's actually quite reasonable. So you see the other computer waiting there, like with the
Thomas, it's
frog and the
10 o'clock
helicopter.
Eastern time, but I'm gonna let you go another 5 or 10 minutes.
Yeah, like I can answer a few questions because that is essentially it. That's like some inspiration of what you can do with WebRTC and a little walkthrough on how it can be done. I have one more demo which I found pretty pathetic, but it's kind of cool. Just to round it off, so I have this little selfie problem. I don't know if you ever thought about this being a thing. If you still can't see my video, I'm in Asia, so I have one of those selfie sticks here. They're vastly available everywhere, and it looks ridiculous watching people taking pictures with them. And if you actually put your phone up there, you have usually one problem, which is, holy crap, how do I capture the picture now? And so if you stick it up there, essentially like this, right? And then like you hold it like far away, and then you can't reach the trigger button of your camera with your finger. So I thought like, well, I know, I think WebRTC can help here because it works incredibly great to like connect two browsers. So I wrote this little selfie demo, which I'll just load in Opera on this Android device. It will ask me for access to my camera, which I will share. And so now my camera picture through Wi-Fi pops up here on the screen, which I hope is still shared. So you can see me here reaching from my selfie stick. And the cool thing is now I can essentially capture from my computer a picture. And then it shows up in the bottom line. So this way I can give you a little look of Singapore maybe, in case you have never been or never seen it. There we are, like we're pretty central here. So there you go, Singapore skyline with the flyer in the background, and like we can take a picture of that too. So again, it uses the same technique. It captures a little video, a little picture from the canvas, and then sends the high resolution JPEG file to the dashboard. Now I need to go away here again. Through the WebRTC data channel, it's called. So it actually sends the JPEG file. FYI, for this to work, you both need to be on the same internet connection, meaning your phone and your other device. It uses your IP address as the room identifier, your public IP address, so that you join automatically. You don't need to say like, hey, I want to be in room XYZ. It uses your IP address to identify that you're on the same network. So it works great if you tether through your phone, for example, when you're on the go with selfie sticks. So that's my little demo time. There's lots of crazy stuff you can write with WebRTC, and I think and I hope we made it very, very easy for people to get started with. And it should be a lot of fun to play around with. I have usually a lot of fun playing around with it. So feel free to give us feedback. We have a live developer chat there as well, where you can get help with it in case you need something. I know a lot of people tried out the co-working demo, and you see a lot of people joining and saying hi. So that's pretty cool. Let me know if you have questions in the chat. I'm happy to answer a few. And other than that, I can only thank Chuck for the opportunity to share this with you.
All right, it looks like there are a few questions. One that came in a little bit earlier was, what is an ICE server and an ICE connection?
So ICE is it's not a server. ICE is a protocol. So maybe I go back to my slides here. So there's very, very weird, complex looking one. Here. ICE stands for interconnection establishment or candidate exchange, something, interconnectivity candidate exchange. So if you have two devices to introduce each other, they need to exchange possible options to connect to each other. What is the network and port and a few other configurations on how I reach the other party. And that process is called ICE. And one network option to connect to is called an ICE candidate. And so there are two forms of this. The typical ICE is your browser looks at all your network options, gathers them all, and then sends them out to the other party through the signaling server, through this known party. And the other party then checks them out one by one and sees what works. The other one is called trickle ICE, in which case the party that offers all the network options sends them out as soon as it finds them. Meaning if it sees, oh, there's one port open here or that I could open here, I send that over directly to the other party through the signaling server, so that the connection establishment can be faster potentially, because with normal ICE it can take, depending on the timeouts of network interface lookups and so on, sometimes up to 20 seconds before all the candidates are bundled up and sent over the wire. So with trickle ICE, which is the standard that we use, it's a lot faster.
All right. The next question: have you attempted to communicate the variances back to the browser vendors so they may fix them?
Yes, actually. So our company, Temasys, is on the W3C committee for WebRTC. So we have a lot of these discussions in the committee itself. We talk to the guys at Firefox. We talk to the guys at Chrome. That's how we got to work with Ericsson on a small unambitious project called WebKit that we have some engineers swearing a lot about these days. Yeah, more on that maybe end of this year. Let's see.
All right. This is another question. I actually asked this one. I may have missed it, but is there any way you can do one-way streaming? Because it seems like a lot of this is two-way communication.
Yes. So WebRTC is great for low latency multi-party because the conversation needs to have very, very low latency. Now, if you say you want to stream it out like this click webinar to like 100 or 200 people, what you would need is with WebRTC, or the way how I imagine it working, I'm still trying to create something like this. You have a server peer, like the same way you can have a client join a room context in a session, you would have a server join a room context as or a session like that. I call them server peers or service peers, really, because they're like normal users, but they are computers. And that computer would take all the video streams from everybody else in the same way a normal client would, but then put them all together in one video and stream it out through whatever streaming channel you can imagine. So I think that would be the way to create something like Click Webinar or a massive Hangout session where you stream it to hundreds of people with WebRTC. And we're actually working in the background to create a service like that you can essentially from your client side offer a button stream, and it would go out to the signaling server and invite a service peer to join your room context to be able to record the session and give you a recording of it, or stream the session live, or be an answering machine for a phone call, or offer speech to text translation services, or whatever else. Like there's so many interesting ideas on what you could build with a service peer. And I see one more question.
Just factor on something like that.
Limiting in terms of amount of users.
Yeah.
So to have them in a real-time conversation, I think you will always be limited to, I think the highest that I've heard is 100. And that involves a lot of MCUs, meaning these mixers that take one video from everybody and mixes them into a big video that it streams out to everybody else. And then they essentially stack them, meaning you have one MCU joining another MCU, so that like one video is becoming a 25th of another video, being a 25th of another video. It's like Inception in a way. You stack them up. So this way, like with every layer, you add latency again, which you don't want, because you want talk and response to be not far further away than a second. So it becomes very, very challenging to do real-time conversations through the internet with more than 15, 20 people, and very, very few companies or offers out there technically can go to 100 at the same time. What they all usually do, like Click Webinar, is right now it's only me and you in the real-time conversation with audio and video. So we get a low latency kind of connection, and everybody else is receiving a stream. And the thing with the stream, the traditional stream, is it can be delayed. And you notice this sometimes if I type a chat, you might see the message before you see me typing it, because you might receive this video delayed. And only if the click web or you get invited by the presenter to join this audio video, you join this real-time conversation and become part of what is streamed. So this is how they hack their way around it. But then, to be honest, I don't see a big reason why you would want 100 people talking to each other at the same time. That's a bit weird.
Yeah, I was just thinking one, maybe two presenters just streaming their.
So you could do maybe 15 like that, and with WebRTC and a normal computer these days, you can do 8 to 10 in your browser already. And if you use our SFU service, you could maybe do 12, 13, and on mobile maybe 5. The SFU is specifically good for mobile because the mobile phones have lesser CPU power.
All right, one other question: does mobile Chrome on iOS support WebRTC?
So Chrome is effectively still WebKit on iOS. They share the same engine, it's just a different user interface. So if you actually think you're using the Chrome rendering engine on iOS, you're wrong. It's still Safari in the background. Therefore, you don't get WebRTC support on iOS. You would need to have this Ericsson browser called Browser, which is not as great of a user interface, but they have attached to WebKit this WebRTC interface.
All right. Any other questions before we end the call? All right. I never did post this to the list or to the forum, but before we wrap up, I just want to let you know that both speakers tomorrow canceled, and so we're going to have Brandon Hayes and Ben Lupton speak to us. Brandon's going to talk to us about refactoring code from jQuery over to Ember, but it's pretty applicable to other frameworks as well. And Ben is going to be talking to us about his experience in JavaScript over the long years that he's been doing it. So I'm excited for those talks. And that's all the announcements I really have. I'll make sure that I announce those on the list as well. Thanks, Thomas, for the talk.
Pleasure. Thanks for having me, Chuck. I hope it was all rather clear.
I thought it was terrific. So
cool.
Yeah, so I'll get these up tonight. Thank you all for listening. Thank you, Thomas, for speaking, and we'll catch y'all tomorrow.
Cool. Cheers.